Problem 52. Considering each of the given ball and stick models, here they are, does the dark red atom have one or more lone pairs of electrons on it? So looking at the dark red atoms, explain your choice, give an example of a molecule that has the indicated geometry. So these right here, the ball and stick models, show you the shape. Okay, so looking at these and the central red atoms, first, are there any lone pairs on these central red atoms? And then explain your choice and give an example of something that has this shape and that shape. Now, to figure out what these shapes are, we can use table 4.2 as a guide. So table 4.2, first of all, looking at this one, this looks like a perfect triangle. This is the trigonal planar geometry, and you can see that this is, so here are all the geometries. You can see that this one is that one. It's called trigonal planar. Okay, so I'll label that one trigonal planar. And there are no lone pairs on the central atom. So you can see lone pairs, so sometimes there's a lone pair, but not on the trigonal planar. There are no lone pairs. So I would say 0 lone pairs. And as far as explaining your choice, does it have lone pairs or does it not? I said it doesn't. 0 lone pairs. To explain the choice, I'd say, well, that's what table 4.2 says. Okay. This, the trigonal planar geometry does not have any lone pairs, according to table 4.2. Now looking at B, you have the central atom here, and then 3 other atoms kind of, they're not in a perfect triangular fashion, but kind of squished together. And this looks like that structure down here, the trigonal pyramidal. And you see this one has a lone pair, and it's even drawn right there. Okay, so this is trigonal pyramidal. Don't get these confused. Planar and pyramidal. Trigonal pyramidal. And there is 1 lone pair according to table 4.2. Okay, now as far as the second part, give an example of a molecule that has the indicated geometry. So give an example of a molecule that has this one, and an example of molecules that has that one. Now we just saw examples of these back in problem 48. BBR3, okay? BBR3 has trigonal planar geometry, so I'll, BBR3, here's its Lewis structure that shows the geometry, and then the trigonal let me show you that one. There it is. And then one with the trigonal pyramidal is NBR3, has trigonal pyramidal. That's the Lewis structure, and here's 3-dimensional Lewis structure. So if you want new examples, then how about this? For A, how about BCl3? Okay, instead of BBr3, we got BCl3. So you got boron with its 3 valence electrons. Boron is in group 3A, 3 valence electrons, and then the chlorines are right next to the bromines, so 7 valence electrons. Right there, right there, right there, and another one. I did bromine, didn't I? So let me put chlorine in there. 7 valence electrons. Chlorine over here. 7 valence electrons. Let's connect the electrons, make the bonds, and you can see this has connected to 3 atoms and doesn't have any lone pairs. 3 atoms, 0 lone pairs. So that is a good Lewis structure. Once you have the Lewis structure, you count the number of atoms, 3 atoms, 0 lone pairs on the central atom. Going back to that table, look for 3 and 0. 3 atoms, 0 lone pairs, that's trigonal planar. So that's another structure. So that's an example of one that's trigonal planar. Another example would be BH3. Okay, BH3 would look like this. Whoops, get back here. Okay, there are several examples. BF3. Trigonal planar structures is, that boron likes trigonal planar structures, but some other ones, NO3 minus, the nitrate anion is also a trigonal planar structure, and the carbonate CO3 minus 2. I'll leave it up to you if you want to draw the Lewis structures for those. I think I did them in we did nitrate earlier in one of the homework problems, and then we did carbonate maybe in the videos for the lecture. Anyway, lots of examples for trigonal planar. What about the trigonal pyramidal? So B, trigonal pyramidal. Well, we saw an example of that in our previous problem. Phosphorus tribromide. Okay, that's trigonal pyramidal. You got central phosphorus, 3 atoms, 1 lone pair. So look for 3, 1. 3 atoms, 1 lone pair. That's trigonal pyramidal. And then, so for part B, we'll list the one that we saw in problem 48, phosphorus tribromide, and then there was also another one in problem 48, nitrogen tribromide. Let's get back here. NBr3 was also trigonal pyramidal. So let's write that down. And oops, get back here. Sorry about that. NBr3. There's many examples. Well, a couple ways to get examples is, you have the same central atom. You just pick other atoms that are in the same column as bromine, and they'll bond just like bromine does. So, bromine is a halogen. So let's swap bromine for, like, let's say fluorine. So how about NF3 or NCl3, and or maybe PI3. How about that one? You got iodine. Okay, and I'll leave it up to you if you want to draw the structures for these.